Hi everyone, my name is Tony Xavier and welcome to another series of the Bell the Cat videos. These videos are a set of companion videos to my book Bell the Cat, Your Friend, Philosopher and Guide for Cat Prep. In this set of videos of DILR, we are looking at mathematical reasoning, sets which involve you to know some amount of mathematical concepts before you can proceed. And in this video, we'll be looking at a set based on PNC. Now, PNC can seem very scary for a lot of people even to attempt in quant. But if you ask me, the only thing that you need to know in PNC is a single formula, which is NCR. How many ways can you select R things out of N things? Everything else can be either advanced or is derived from this. But how many ways can you select R things from N things? NCR, and if you know what the formula is, N factorial by R factorial into N minus R factorial at the denominator. If you know that and you have reasonably good logical reasoning skills, you should be able to do the job. And what usually happens in a PNC set, as we will see in this set, is that even if you're not really an expert, if you know a few basic formulas or just this basic formula, you'll be able to pick out at least 2 questions and get 6 marks and get out of it, right? We look at a set, we look at the questions that are there, and we won't do all the questions because I would want to solve it exactly what I would do in the exam, because PNC, you have to list a lot of cases, right? And in that listing of cases, things can get complicated. So it is better that you leave those complicated questions, get 6 marks in 5 minutes and step out of there. Now let's look at this set. This is also an actual CAT set. What does it set say? A new airline is planning to start operations in the country. In this country, how many cities are there? 10 cities are there. They have a very simple rule. Any 2 cities should be connected in such a way that somebody should be able to go in the morning and come back in the evening. That's a simple rule, right? So if I have 2 cities, A and B, I should be able to leave at from A in the morning, reach there at B. I should be able to leave B in the morning and reach A and get back in the evening. So morning, evening flight, right? So they said that the flight duration between any pair of cities will be less than 1 hour, and these are the rules. So nothing much beyond this, and straight away we go to the questions. First question: if the underlying principle is to be satisfied, that any pair of cities somebody should be able to do a day trip, right? Then the minimum number of direct flights to be scheduled is. Then what's the minimum number of direct flights? Now, how do we solve this? If you see, this question is actually testing the most basic elements of PNC and logic at the same time in a CAT paper. If you ask me, if you know this particular question, there won't be an easier way to get 3 marks. Now, what is it saying? Between any person in any of these cities should be able to make a trip to another city morning, evening, right? Now, let's take any 2 cities, A and B. So from A, 1 flight should go in the morning and 1 flight should come back in the evening from B, right? From B, 1 flight should leave for A in the morning and 1 flight should come back from A to B in the evening. So between any 2 pair of cities, what is the minimum number of flights that you need for the condition to be satisfied? 4. So between any 2 cities, you need 4 flights. Now, totally 10 cities are there. 10 cities, and how many pairs of cities can there be? Can you choose out of 10 cities? The formula is simple. How do you choose R things out of N things? That means NCR or 10C2, right? So how many unique pairs of cities are there among 10? 10C2. 10C2 is nothing but 10 into 9 by 2, that's equal to 45. So 45 pairs of cities are there, and for every pair you need 4 flights minimum. So 45 into 4, 45 2s are 90, 92s are 180, the total is 180. So that's our required answer, right? Now if you see, the initial information given is very, very simple, right? Barely anything in the set, right? So now you know that if this is the easiest question, the next question will have additional information and some complication, and then after that, so on and so forth. Right now, then your call is to look at what is the complication I can handle, get those 3 marks quickly and leave, and where will I have to go into long calculation, and it will end up taking definitely more than 2 minutes per question. It will go to 3 minutes per question or 4 minutes, right? Now, if you look at the next question, small change. 3 of the 10 cities are developed as hubs. Some 3 cities are developed as hubs, and which are connected by any other city both in the morning as well as evening. So these 3 cities are hubs, and they're connected to every other city, right, morning as well as evening. The only direct flights which will be scheduled are originating and terminating in one of the hubs, right? So only direct flights will be either starting from one hub or ending in one hub, ending in hub. So what does it mean? In these non-hub cities, there can be no flight that starts from a non-hub city and ends in a non-hub city. It's either starting in a non-hub city and ending in a hub, or starting in a hub and ending in a non-hub, right? Now, then the minimum number of direct flights that need to be scheduled so that the underlying principle of the airline to serve all 10 cities are met without visiting more than one hub at a time. So they're saying simple case, same as before. Somebody should be able to do a morning and an evening, right? So between any two pair of cities, there are 4 flights as usual, right? The only difference is that a starting or an ending can only happen in a hub. You cannot have 2 non-hubs, right? So that is the. Now, how do you go about things? So we know everything. Suppose there are these 10 cities. Now you choose any 3 cities as hubs. Let's say ABC is hub. So you choose any 3 cities as hubs. So this is a hub and the rest of the 7 are non-hubs, right? So whatever are the 3 hubs, now what are the cases that we have? Only direct flights which are scheduled and originating in one of the things. This much we know, right? Select a pair of cities, right? These are hubs. These are non-hubs, right? Now the names can change. It can be DAF, ABC, that doesn't matter. We're just looking at 3 and 7. Any set of 3, any set of 7. Now, what can be first pair of cities? First pair of cities can be both the cities are hubs. So if both the cities are hubs, that's a pair, right? How many pairs, such pairs can be there? You have 3 hubs. And out of that, how many pairs of 2 are there? How many ways of selecting 2 things out of 3 things? That is 3C2 or nothing but 3. So 3 hubs, you have to select 2 out of 3, that is 3C2 or 3. So 2 hubs. What other pairs can be there? Hub non-hub or non-hub non-hub. But is non-hub non-hub possible? No. It has to be either starting or ending in hub. So both can be hubs or hub non-hub. So hub non-hub, right? So you can select one city from a hub and you can select one city from a non-hub and make pairs, right? How many hubs can you, how many ways can you select one hub out of 3 hubs? Any one hub out of 3 hubs, right? That is 3C1. How many ways can you select one non-hub out of 7 non-hubs? 7C1, 7CR. Number of ways of selecting R things out of N things, right? So any of these 3 hubs can have a combination with any of these 7 non-hubs, right? So that is what? 3C1 into 7C1. So how many combinations are possible between a hub and a non-hub? That is 3C1 into 7C1 or 21. So totally how many pairs of cities can you select for scheduling these flights? 3 plus 21, 24. And we know the old rule. What is the old rule? Between any 2 pairs of cities, the minimum number of flights has to be 4. I have 24 pairs of cities and I have 4 cities, 4 flights per pair. So what's the number of combinations that is possible? 24 into 4, that's equal to 96. Yeah. So that's the number that I have. Now, you go to the next question. So if you see, this also is fairly fast. Maybe the first one would have taken a minute and a half. I explained to you I took so much time, but otherwise it's barely even a minute. This one, maybe you would need to take 2 minutes. Now then, what's the next one? Suppose the 10 cities are divided into 4 distinct groups, G1, G2, G3 and G4, having 3, 3, 2 and 2 cities respectively, such that G1 consists of cities named A, B and C. Okay, G1 is A, B and C. Further, suppose the direct flights are allowed between only 2 cities satisfying one of the following conditions. Both cities are in G1, between A and any city in G2, between B and any city in G3, between C and any city in G4. What's the minimum number of direct flights that satisfy the underlying principle of the airline? So we know that they've given the direct flights. Now you have to sit and list the cases and do that, right? So both cities are in G1. So you have 3 cities in G1, that is A, B and C. How many ways can you do it? 3C2 or 3. Now for this 3, you will calculate the total. Between A and any 2 cities in G2, between B and any 3 cities in G3, and between C and this thing. So you'll do that whole calculation. It is a bit long and painful, and you might tend to make a mistake. It is easy only, it's not very tough. But at this stage, for example, PNC is not your strength. and this is you've already solved 2 sets and you've cleared the cutoff for sure, then the best case to do is, if you come into this at 5 minutes, solve the first 2 questions, get the 6 marks and get out of there, right? So this one and this one, the next question is also based on the same thing. What would be the maximum reduction in the number of flights as compared to the situation before the operational difficulties in area? It's an other question, again based on the same this thing. So it's not a bad idea to leave this. Now those who are good at PNC will definitely go and say, I need to do both of these. Yes, you can do both of these if you're good at PNC, absolutely not a problem, right? So those who are really good at quant and also good at PNC within quant, you know that this you can do. But that is a very small proportion of people from my experience with students. So everybody else, if you're overwhelmed by PNC as a concept, the least you could do was at least the first question and get 3 marks, and the best you could do was do the first 2 questions, get 6 marks and step out of them, right? So what I wanted you to look at through this set is that not all PNC, you don't need to know PNC, you don't need to become a champ at PNC. You only need to know the basics and the rest is logic. You need not attempt all the questions in the set. Right? You don't need to attempt all the questions in the set. You can just attempt a few, get 6 marks and get out of that, right? So I hope this was useful and this will give you that confidence to attempt at least a low-hanging fruit PNC set right from now on. And remember, all you need to know is NCR and the formula for that and nothing more. The rest is all logic. Thank you.